In this video we'll be looking at expanding perfect squares using the distributive law. Before I get into that, just some examples of perfect squares. For example, 3 squared is a perfect square, a squared is a perfect square, and 2y squared is a perfect square. Something like this, x minus 3 to the power of 2, that's a perfect square, and so on. So these are all examples of perfect squares. Alright, well here we go. I'm going to expand this perfect square just using the letters A and B to start with. So I'm going to rewrite this, and I can rewrite it as A plus B followed by a second bracket of A plus B. How did I get that? Well, A plus B squared means A plus B in a bracket multiplied by A plus B in the second bracket. And now I'm going to use my distributive law, so I'm going to go A multiplied by A multiplied by B, and then B multiplied by A, and B multiplied by B. So I should end up with something looking like this. A multiplied by A is A squared, A multiplied by B is plus AB, plus B multiplied by A is BA, plus B multiplied by B is B squared. Alright, the next thing I need to do is have a look at these over here, these terms, and see if I've got any like terms. And I can definitely identify that AB and BA are like terms, so I'm just going to add them together. So I end up with A squared plus 2AB plus B squared. And that should be your answer. Right, well let's have a look at this one. Remembering in the previous example, this over here was actually a positive, so it was A plus B squared. This time we've got a negative, and nothing really changes, so we can pretty much expand these brackets to be A minus B multiplied by bracket A minus B. And once again, we're going to use the distributive law, multiplying A by A and A by negative B, and then negative B multiplied by A and negative B multiplied by negative B. And it should end up something like this. A multiplied by A is A squared. A multiplied by negative B is negative AB. Negative B multiplied by A is negative BA. And negative B multiplied by negative B is positive B squared. And once again, I'm collecting my like terms. I have 2 of those, so I can collect them. My answer therefore will be A squared minus 2AB plus B squared. Alright, well, how about giving these 2 examples a go? Put the video on pause and come back when you're ready and see if you got them right. So A we can rewrite to look like this. Is going to be x minus 3 multiplied by x minus 3, and I'm going to use the distributive law, so I'm going to get x squared minus 3x, and then I'm going to use the other one minus 3x, and I'm going to go plus 9. So my answer here should be x squared minus 6x plus 9. Alright, and similarly over here I can rewrite it as 2x plus 2 in one bracket multiplied by 2x plus 2 the second bracket, because they are a perfect square. So 2x multiplied by 2x is going to give me 4x squared. 2x multiplied by 2 is going to give me just 4x. 2x multiplied by 2x is going to give me another 4x, and 2 multiplied by 2 is going to give me a 4. And I have some like terms that I can collect, so therefore it's going to be 4x squared plus 8x plus 4. Hope you got those 2 right. Alright, well now we're just going to have a quick look at the difference of perfect squares, and sometimes it is written as DOPS. And this can be best explained by saying in one bracket we've got A plus B, and in the second bracket we've got A minus B. And essentially, if we use the distributive law and we multiply A by A and A by minus B, and B multiplied by A and B multiplied by minus B, we end up with something looking like this. A squared, and then a multiplied by minus b, it's going to be minus ab. Then positive b multiplied by a is going to give us a positive ba, and a positive b multiplied by a negative b is going to give me a negative b squared. And then once again we have some like terms that we can add together and or subtract. So those two added together are actually going to be nothing. So it's going to be a squared minus b squared, because this and this equals 0. Alright, well, using that information, see if you can expand this bracket and come up with some perfect squares. Put the video on pause and come back and check and see if you got it right. Alright, well, I'll end up with x multiplied by x is x squared, x multiplied by negative 3 is negative 3x, then positive 3x, and then negative 9. 3 times 3 is 9. So therefore it gives me x squared. These two guys cancel each other out, and minus 9. And an alternative writing that would be x squared minus 3 squared. Alright, so both of those would be correct. Alright, well, that's the end of perfect squares and the difference of perfect squares.